Good day. We are doing part 2 of differentiation. We are doing higher derivatives. The higher order derivatives are used to determine and or confirm maximum, minimum, and inflection point. So you will see as we do that. For an example, so we have the first derivative, we say it's f prime. First derivative is f prime. And then the second derivative is f prime prime. Then the third derivative is f prime prime prime. Okay. So we have an example here. It says find the first, second, and third derivative of the following function. So our function is y is equals to 10x plus x to the power of 0.5. Remember, I said that y is the same as f of x. Remember, I said that y is the same as your f of x. Okay, so I'm just going to use f of x. So remember, we said that when we derive prime, it's going to be f of x is equals to n, then x to the power of n minus 1. I'm just reminding you of the power rule, if you remember the power rule. Okay, so we are going to start by doing the first derivative. So the first derivative, so we are going to say it's f prime. I'm just going to use a red pen. F prime is equals to, then remember here there's a 1, so this will be 10 times 1, then x to the power of 1 minus 1, and then I'm just going to use brackets, then plus, and then this is 0.5 x to the power of 0.5 minus 1. Okay, so we are deriving this, the first derivative. This will be 10, then x to the power of 0, then plus 0.5, then x to the power of negative 0.5. So final answer will be 10. Remember, x to the power of 0 is 1. So just to remind you, x to the power of 0 is 1. Okay, 1 times 10 is 10. So this will just be 10 plus 0.5. 10 plus 0.5, then x to the power of negative 0.5. I'm not going to change this negative to be a fraction because I have to derive again. So I'm going to take this and derive again, second derivative. So this will be f prime prime. So I'm going to take my answer of the first derivative. So this will be derivative of a constant is 0. Derivative of 10 is 0. And this is plus. And then open bracket. Then we say 0.5 times negative 0.5. And then this will be x to the power of negative 0.5 minus 1. And then this will just be 0. And then this times this will be plus negative, okay, it's just 1/4, okay, 0.5 times negative 0.5. We get a negative 0.25, and this is x to the power of negative 0.5 minus 1 is just negative 1.5. Okay, so final answer will be negative 0.25, then x to the power of negative 1.5. So this is our f prime prime. Okay, so now we have to look for the third derivative. It's prime prime prime. So I'm just going to use the purple just to be consistent. Okay, so prime prime prime, we are going to have, oh, sorry. So it means I'm going to take my final answer. I'm going to take this answer and then use it. Okay, so here we took this answer. This was just f prime x. So we took this answer and used it to find our second derivative. So I'm going to use the answer that I got here to find my third derivative. Okay. Then when we take this answer, this will be f prime prime. Then it's going to be negative 0.25 times negative 1.5. Then this is x to the power of negative 1.5 minus 1. And then the answer will be, if you want to write them as fractions, it's still fine, but I just want to write them as decimal numbers. Negative 0.25 times negative 1.5. This will be 0.375, and this will be x to the power of minus 1.5 minus 1. My answer will be negative 2.5. So if you want, you can write these answers as fractions. It's going to be fine. So this one, if you write it as a fraction, let's say your final answer is a fraction. Okay, let me start here. So your final answer here is a fraction. Your final answer here is a fraction is f prime x is equals to 10 plus, I'm just writing it as a fraction, and then this is x to the power of negative 1 over 2. Just in case you don't get confused, don't get confused. And then this one, when I write it as a fraction, because some of your calculators will give you a fraction, so this will be 1 over 4, so this will be negative 1 over 4, and then x to the power of 3 over 2, I think, 1.5, it's 3 over 2, so this is going to be negative 3 over 2, okay? And then I'm just saying in case you were using your calculator and then you saw fractions so that you don't get confused. Okay, this one is, okay, I'll just do it this way. This one is 3 over 8, so this will be 3 over 8, and then x to the power of x to the power of negative 5 over 2. If you want to make this negative a positive, then therefore this will be 3 over 8, then 1 over x to the power of positive 5 over 2. Okay, so same thing with this one. This is the same as 0.375, then 1 over x to the power of 2.5. If you want to make this 2.5 positive, or if you want to make the 5 over 2 positive, you just make it a fraction. Okay. All right. And then now, so this is what we call the higher derivatives. Okay. If they want a derivative, fourth derivative, you derive your answer. Okay. And then now let's look at optimization and stationary points. Stationary points are your turning point. So a stationary point is your turning point. So this is the same as a turning point. We call them stationary points when we do your cubic graphs. Cubic graphs is the graph that turns more than once. A graph that turns like this, something like this. It has two turning points. That's what we call a cubic graph. You'll see what I mean as we go on. Okay, so they're saying that optimization is the process of finding maximum and minimum points. And then at the stationary or turning point, the slope is 0. Okay, so it means that here, where your graph turns here, the slope is 0. There's no gradient here. Okay, if you remember, the slope is the gradient. Okay, so they're saying that the condition for stationary points is that the derivative must be equal to 0. So meaning that the slope must be 0. Okay, the first derivative must be equal to 0. Okay, maximum and minimum turning points, which are your stationary, the turning point of a function. You will see that it's a derivative is equal to 0. So it's the same as f prime. Sorry, it's the same as f prime is equals to 0. Okay, and then they're saying that the maximum turning point is your second derivative. This d2 is your second derivative, so it's your f prime prime x, f prime prime x. Okay, don't be confused. So the maximum turning point, the second derivative is less than 0. And then the minimum turning point, your second derivative is greater than 0. Okay, so meaning the negative and the positive. We know that less than means negative, greater than means positive. Okay. All right. So they're saying to determine whether the turning points are minimum or maximum points, you substitute x values into the second derivative. Don't forget, you substitute your x values that you got into your second derivative. Okay, we'll see what that means. So let's look at the first example. The example says find the turning point of the curve. So this graph, this is what you call a cubic graph. There's a cubic function because of the cubed. Okay, so this is what you call a cubic function. This 3 tells you that this is a cubic function, so the graph is going to turn more than once sometimes, but it's a cubic graph. It looks something like this. That's a cubic graph. This one has 2 turning points. It depends on the function though, but the cubic, it's a cubic graph. Okay. So here they're saying that remember x is equals to, so this we use it when we want to solve for x. When you solve for x, you use what we call the quadratic formula. We used this, if you remember. This we use it to solve for x. So I'm just reminding you the quadratic formula. Okay, so so they're saying that when you find the turning points of the curve, the first thing you need to do is to differentiate. So you have to find the first derivative. Okay, we differentiate. So when we differentiate, we are going to remember our f of x. Remember I said y is equals to f of x, so it's the same thing. So remember we have our f of x is equals to x to the power of 3 plus, okay, I don't know why am I using a red bracket, it's fine, plus 9x squared minus 24, sorry, x then plus 26. So when we find the first derivative, we are going to have, remember, when we derive, I'm just going to remind you, it's 3, then x to the power of 3 minus 1, if you remember, for the x cubed, then plus, and then it's 9 times 2, if you remember, then this is x to the power of 2 minus 1. Okay, I'm using brackets so that you can see I'm differentiating this function one by one each term. Okay, so and then this one is 24. Remember, this is times 1. There's always a 1 here. And then this is x to the power of 1 minus 1, bracket, then plus. Remember, the derivative of a constant is 0. Derivative of 26 is 0. Then my final answer will be 3x to the power of 2. Then plus 9 times 2 is 18. Then x to the power of 1. And then minus 24. And then x to the power of 0. Okay? So remember, x to the power of 0 is just our 1. So it's 1. So this will just be 18x to the 1 minus 24. Because x to the power of 0 is 1. Don't forget, x to the power of 0 is equals to 1. Okay. And then now we move on to step number 2. Step number 2, now they're saying set your f prime equals to 0. So they're saying that you must just set this. Remember your first derivative is 3x squared plus 18x minus 24. So they're saying that you must set this to be equal to 0. So it means that you must just say 3x squared plus 18x and minus 24 is equals to 0. I'm just doing this step by step, but because our questions are multiple choice, this will be easier. But when you do it, you just do it as a whole thing. Okay. All right. So after that, we need to solve for x. So when you solve for x, remember, we have 3x squared plus 18x minus, you can factorize if you want. So I'm just using the quadratic to help those who don't know how to factorize. So this helps us to solve for x. Can either factorize or use the quadratic formula. It's up to you. Okay. So then now we're going to solve. So remember, we need to find our A is 3. Our B is 18. And then our C is negative 24. And then now we can solve. So this will be X is equals to our B. So it's negative, our B is 18. Plus or minus. So remember, plus or minus tells us that we're going to have two answers. Plus or minus. And then the square root of our B is 18. So it's 18 squared minus 4. Our A is 3. Our C is negative 24. And then everything over 2A. Our A is 3. Okay. So we are going to have two answers. So X is equals to negative 18 plus the square root of, just use a calculator. So it's 18 squared minus 4 times 3 times negative 24. So we have 612 over 2 times 3 is 6. Then I say or my X is equals to negative 18, then minus the square root of 612. It's the same thing, then over 6. Okay. Then now we get the answer. 18 squared minus, okay, just want to see first, I'm confirming if my answers are correct. Okay, and then now it's going to be negative 18, the square root of 612 over 6. Okay, something, oh yeah, made a mistake, sorry, it's plus. Okay, I made a mistake somewhere. 4ACA is 3. Our 3 is, okay, let's see, is it negative? 2 minus, oh yes, I made a mistake here, sorry. This is negative. Oh, I apologize. This is negative, negative, negative. Ooh. Yeah, I made a mistake. This is negative, negative. Gosh. Yeah, I can see that my answer is not right. Okay. Sorry about that. This is negative. This is negative. This is negative 3. Okay. So we have yeah, I apologize about that. Yeah, it's negative. Yes. Okay. So it means this will change. Sorry about that. So this will be 18 squared minus 4 times negative 3 times negative 24. Yeah, I made a mistake. Ooh. Okay, this is 36. I apologize about that. Okay, so now it's 18 minus, sorry, plus square root of 36. Then divided by 6. Okay, the answer this side. So our x this side is 4. And then the x this side, let's see, negative 18 minus divided by 6, okay. Okay. Then this side we are going to have, okay, let me see, negative 18 plus, I'm pressing the wrong things. This is negative 2. And then this one, I just changed this to be a negative. This one is negative 4. Okay. All right. So this is how we solve for x. Again, please also confirm, always confirm this, because I made a mistake. I missed that negative is very important. I missed it. And it caused me to have decimal numbers. All right. Okay. So that's the answer. And then now we move on to step number 4. We find the function value. The function value meaning that you are going to use this -2 and -4 to find the y value so that you can find the turning point. Turning point, it must have the x value and the y value. So we are going to find, remember our function is f of x is equals to -x to the power of 3. Then this is plus is plus 9x squared minus 24x, then plus 26. So when we find the function value, you have to use the original. Use the original function. Not the derivative, but the original function. Okay? So it means that now we're going to start with f at -2. So it means that wherever I see x, I'm going to put -2. This will be negative. Then we put a -2 to the power of 3, then plus 9, -2 to the power of 2. Did I get the -2? Okay. Gosh, why do I keep making mistakes? This is negative. Oh, I'm so sorry, guys. I'm making mistakes. This is negative. It's -6. So this is gonna change. Be a negative. This will be a positive. I apologize. Okay. Then this is 2 minus 24. My only mistake is this negative. I don't know why didn't I change also there. Okay. I am sorry. And then now the final answer will be when we substitute here. So this will be negative open bracket 2 to the power of 3 plus 9, then 2 to the power of 2 minus 24, and 2, and plus 26. Then the answer will be the answer will be 6. So it means that the turning point here is x is 2, and then y is 6. So our graph is going to turn here. And then for the -4, for the -4, we are going to have negative. Wherever you see x, we put -4, and then plus 9, and then minus 24, and then plus 26. And then this will be equals to 10. So this means that our graph is going to turn at -4 and 10. All right. So these are our function values. So I already answered number 5. So there's no need for this. So our turning point is 2 and 6. The other one is -4 and 10. Okay. So remember, these are just the steps that you follow to get the turning point. So we have the turning point. And then the following question says, determine which point is a maximum and minimum by using the second derivative. So maximum and minimum, we are going to firstly find the second derivative. So remember, our first derivative is f prime x is equals to -3x squared, and then plus 18x minus 18x, then minus 24. All right. So when we find the second derivative, so this will be f prime prime, we are going to have negative 3 times 2, then x to the power of 2 minus 1, and then this is plus, then it's 18. Remember with the 18 there's a 1 here, so it's 18 times 1, then x to the power of 1 minus 1, and then minus 24, it's 0. And then this will be negative 6x to the power of 1, then plus 18, then x to the power of 0, which is the same as negative 6x plus 18. That's our second derivative, f prime prime. Okay. And then now after we find f prime prime, we are going to now find, what is it? The minimum and the maximum using the second derivative. Okay. So we are going to check with our turning points whether it's a minimum or maximum. So let's start with at 2 and see if it's a minimum or maximum. So it means we're going to substitute x is equals to 2 way on our second derivative. Our second derivative is, remember, our second derivative is negative 6x plus 18. So we are going to substitute. So this will be 2, wherever we see x, we put 2. And then our answer will be 6. Negative. Our answer is going to be 6. So this 6 is positive, so therefore it's greater than 0. And then we can conclude and say that we are going to have a minimum turning point. Minimum turning point. And then now we move on to this one. So remember our second derivative again is negative 6x plus 18. So wherever we see x, we substitute 4 now. So this is negative 6, then 4, then plus 18. And then our answer here is negative 6. So negative 6 is less than 0. Therefore, we are going to have a maximum turning point. Maximum turning point. Okay. All right. So when we determine the intervals along a curve increasing or decreasing. So here they're saying that if your f prime x is greater than 0 on an interval, then f is increasing there. And then if f prime x is less than 0 on an interval, then f is decreasing there. So let's remember this: greater than is negative, less than is positive. Okay. Is negative. Less than negative, greater than positive. Okay. So they're saying determine the interval along which each of the following functions increases or decreases. So when you have to determine the interval, you follow the same steps. So I decided to use the same function that we used. I didn't want to go through all the steps. I decided to use the same function that we used just to save time. So the function that we used, this is the first derivative, we found that, and then we set the first derivative equals to 0, then we solved for x. When we solved for x, we used the quadratic formula. Okay, this is the steps that you follow: quadratic formula. And then we found our x value. Our x values are 2 and 4. 2 and 4. Why do I remember putting a negative? Gosh, it's 2 and 4. Why do I keep making these mistakes? Sorry, and I'm pretty sure that you didn't get that. Yeah, it's 2 and 4. Okay, let me confirm again. Yo, negative and then to the power of 3. Just to confirm. Can see that? No, man. Okay. Yeah, it is. Sorry. It's 2 and 4. 2 and 4. 2 and 4, not 2 and negative 4. 2 and 4. And then the second derivative we had negative 6x plus 18. Okay, so we know that at x is equals to 2, our graph it has a local minimum point, and then x is equals to 4 is the local maximum point, so meaning your maximum turning point. Okay, so this is how the graph looks like when we draw it. Okay, so you will see this is the our local minimum, and then this is our local maximum. Okay. Okay, so this is where our two graphs are turning. So this is how a cubic graph looks like. But don't worry, you won't be drawing this graph. Okay, so now when we have to talk about what is it? Decreasing and increasing the intervals. So you will see that from here, starting from this point going to the left, our graph it decreases. So it means that the graph decreases from negative infinity until 2. Our graph is what is decreasing. So increasing, decreasing, you always have to loop. You start from left to right. You move from left to right, okay? Then when you start here, when you move from this point to that point, it's increasing. So we'll see that between 2 and 4, our graph is increasing. And then you'll see from this point to that point is going down, right? So from here going to the right, our graph is decreasing. So it means that we're using the x line. So from 4 until positive infinity, our graph it's decreasing. This is how we see, okay? So please ignore my errors, and I apologize for the errors of the negatives here, but everything is fine so far. So you can follow the steps, and then that's how we do it. So this is just the first part of differentiation. Now we're going to deal with application on our next lesson. And thank you.